Hi, in this Let's Create series, we're creating a lights out puzzle game like this. Over the course of these episodes, we'll create the grid of squares and implement the light toggling puzzle logic. When the lights are out, we'll check for the win condition and display a winning animation. Finally, we'll create several levels and the ability to select different levels. Let's get started. I'm using Unity 6 and selecting the default 2D project with URP. There are no special features we're going to be using here. Any 2D project will be fine. I've deselected the cloud services as we'll not need them. The first thing we're going to do is to create the individual tiles that make up the game board. Right-click to create a 2D object. We're going to choose Sprites Square. This is going to be our light square, so let's rename it Tile. We need to add a script to this to contain our tile logic. Click Add Component and type Tile and create a new script. You'll see that this adds the script to the root directory. I like to keep things neat, so let's quickly create a scripts folder and drag it in there. Let's jump into the tile.cs script now. The goal here is to implement the logic that toggles the tile color. For this, we'll need access to the sprite renderer on the object which contains that detail. So create a serialized field of type sprite renderer called sprite renderer. Next, we're going to need some tile properties. I've added a header here so it separates them in the inspector. The two properties that we'll need are serialized private fields of type color, and we'll call them off color and on color. This will enable you to set the tiles to whatever sort of color you like for this project in the inspector. The final bit for the variables will be the tile state. This is simply a private boolean called isOn, which will default to false. Okay, so we'll need a method to set the sprite renderer color according to the state. Create a new method called updateDisplayedState. This will simply set the sprite renderer.color based on the isOn variable. If isOn is true, we set it to the on color, and if it is off, we set it to the off color. I've used a ternary operator here. The syntax is condition, question mark, value if true, colon, value if false. You could do this with an if statement if you prefer, it's up to you. We want the state to be set when the component is created. So in our start method, we can simply call this new method to ensure the tile displays the off color. We will need two methods for interacting with the state. The first is a public void called toggle. This is public because we'll need to be able to call this on the tile to alter the state. This flips the value of isOn. As isOn is a boolean, I've used the exclamation mark which negates the boolean. Then we need to call our updateDisplayedState method to ensure that the sprite renderer updates the tile to the correct color. The second method we'll need is a public void called setState. This takes a boolean called isOn. We need this to, say, initialize the levels by turning certain lights on or off. This sets the isOn variable of the class to the past boolean. You'll note that I've had to use this.isOn because they have the same name. I could have given the past variable a different name, but I think isOn is the correct name for it, so we just have to live with needing this extra this. And again, we call updateDisplayedState. Whilst we're here, I'll add one extra method called isLightOn. Again, this is public and it just returns the value of isOn. We'll need this later on when we're detecting if all the lights are off for the game's win condition. Okay, so we've got the basic controls here to set, toggle and get the state. However, we still need one more to deal with the interaction. When we click on the tile, we want something to happen. So we'll add a private void onMouseDown that simply calls the toggle method. The onMouseDown is called whenever the user clicks on a collider attached to this object. That's it for the code. So back in Unity, we can set our two desired colors. I'm using a dark red for the off state with a bright red for the on state. Remember to set the alpha value to opaque when doing this. For some reason in Unity, it defaults to completely transparent. We can then drag on our sprite renderer from the object. As I mentioned, the onMouseDown fires when a collider is clicked, so we need to add one of those to our object. So click Add Component and select Box Collider 2D. This will automatically be created the same size as the sprite, so we don't need to update anything there. I've checked isTrigger here. That's just a force of habit. We've not got any physics interactions going on, so it doesn't really matter what type of collider it is. Now we can test this out. Clicking on the tile toggles the light. That looks great. We want to create lots of copies of this tile, so let's create a prefab directory, then drag our tile in there. We can now delete this from the scene as we'll create the whole grid of tiles programmatically. Now we want to create the grid of tiles. We could directly add them to the scene in the center, but then you would have issues if you want to scale or move it later on. What we'll do is right-click and create a new empty game object, which we'll call game area. We'll create all our tiles within this so that we can manipulate this game object if we want to move or resize the tiles. We will also create a new empty game object, and this time we'll call it Game Manager. This is where we'll store our game logic. So create a new script on this object called Game Manager 2. As before, this will create the script in the root directory. So I'll just move it into our scripts directory to keep things tidy. In the GameManager.cs script, we'll need references to the tile prefab and the game area. Then we'll want to create our array of tiles. Because we'll keep needing to refer to the dimensions of this, we'll create two helper variables. These are going to be private static read-only ints called numRows and numCols, which we set both to 5. Then we can define our 2D tile array as private tile. Then we use brackets with a comma to indicate it's a 2D array, and we'll define it straight away as a new tile array using our numRows and numCols variables. This is why they had to be static read-only variables, so we can use them in this way. Now in the start method, we'll create the tiles. To iterate our grid of tiles, we'll have 2 for loops iterating over rows and columns. When talking about tables, we do rows first, then columns. This is because when writing out an array representing a table, you tend to read across the rows. In the code, if you had the whole table, it would look on screen as it does in real life. The first thing we need to do is decide where to put the tile. I'm going to center the tile generation at the origin within the game area. This is where we need to be careful. In Unity, we're using grid coordinates. So X is along the horizontal, which will be related to our column position. So the X coordinate, which comes first, will be col minus numCols over 2. If you have 5 columns, then you can see that the first element will be positioned at 0 minus 5 over 2, which equals minus 2. Note here that all the arguments are integers, so this is integer division rather than floating point. So that 5 over 2 equals 2, not 2.5. If you work this out, you'll see the values we get for cols 0 through 4 are minus 2, minus 1, 0, 1, 2, which is obviously what we want to get them all nicely spaced. This code only works for odd-numbered dimensions. We could make it properly generic, but given we're only implementing a 5x5 grid, that's not worth it at this stage. Just note, you'll have to tweak this if you want to extend this to support arbitrary grid dimensions. Then, it's the same thing again with the row position. Now we can create them. So for tile, row, col, we instantiate the tile prefab with a parent of game area. We'll set the tile name to include its row and column just for our sanity. And the $string formatting here, if you've not seen it before, just means you can put the variables in your strings inside curly braces and they get put in for you. Finally, we set the local position to be our pos vector. It's important that we use local position here because that makes them relative to the game area's position, just in case you move it around. Let's check this out. First, we need to drag on our tile prefab and our game area to our game manager object, so it has the references for it. Then hit play. Wow, that just looks like one big tile. If we expand the game area in the hierarchy, we can see that it's created all of the tiles. So if we switched over to the scene view and click on them, you can see that they're in the right positions and the right size. But what has happened is that each tile is exactly 1 unit big, and we've put them 1 unit apart, so there's no space between them. Let's quickly fix that. Stop play mode. Now, if we go to our tile prefab, we can just make it a bit smaller. To do this, we'll lock the scale so all the dimensions scale together and set this to 0.95 to make it just a little bit smaller. If we hit play again, we can now see this looks much better. My game resolution here is set to 4K and it defaults to real size, so let me just zoom that out so it fits on the screen. As the tiles are in the game area, we can manipulate this to move them around and to scale them if you wish. Remember, any changes you make in game mode don't persist. I'm just going to drop out so I can set the tiles to be positioned at y equals 1.5, so they're slightly to the top of the area. This will leave me with some space for some buttons beneath later. We're going to stop there for this episode. In the next episode, we'll get the dependent toggling set up and some different levels. I hope you found this tutorial useful in some way, and as ever, the full code is available on GitHub and linked in the description below. See you next time.